Okay, so just a little bit more on factoring. So this is just some general strategies for factoring. So one of the things you always want to do is first thing you want to do is look for a common factor, something other than one or negative one. If there are any common factors, you want to try to factor out your largest one, so your greatest common factor. Then we look at at the number of terms. If we have two terms and we try factoring as a difference of squares first. If you don't have a difference of squares, then you're going to try something else. Next, try factoring as a sum of difference of two cubes. And then if they're not two cubes, then don't try to factor the sum. If you sum of a squared plus b squared. So if you have a difference of two squares, try to factor that. If you have a difference or a sum of two cubes, try to factor that. If it is the sum of two cubes, don't try at all. And pretty much anything else, if it doesn't fit the difference of two squares or difference of sum of two cubes, then there's probably not more you can do to factor it. Three terms, you have three terms. Determine whether the expression is a trinomial square. If it is, you know how to factor a trinomial square. Other than that, you are going to try AC method, or you're going to try a reverse FOIL. For more terms, you're going to try factor by grouping. So you may have to regroup it a couple times to get it to work. So you're going to try factor by grouping and removing a common binomial factor. Next, try grouping into a difference of two squares with one of which is a trinomial. So if you can't get it to work, then you're just going to retry it again as a difference of two squares. So we'll kind of see when we go through this. So you always want to factor completely. So remember, factoring completely means that I can't factor it any further. I'm down to my prime factors. And then always check by multiplying to make sure we did it correctly. So we're not going to check every single one of these. We may check a few. So for example, if we have this one here, we have 18, 9, or sorry, y to the 9th minus 27, y to the 8th. So I can at least factor, both of these are divisible by 9, so I factor out a 9. And I can factor out a y to the 8th. So if I do that, I'm just going to be left with 2y minus 3. And there we go, we're factored. That's the best I can do. So once I get there, I got 2y minus 3. That is not it's not two squares, it's not two cubes. There really isn't any more I can do that. So I factored out the largest common factor between 18y to the 9th and 27y to the 8th. And that was the best I can do. Okay, so we got m to the 6th minus 1. So it may not be maybe obvious right away, but we do have, you can either look at this as maybe a difference of squares or a difference of cubes. Because we have m to the 6th, which we know when we were doing all that work with exponents, that's actually just m to the 3rd squared. So you could rewrite this as, or you can say it's m squared to the 3rd. Use one or the other. So I'm going to change m to the 6th as m squared to the 3rd minus 1. So now we actually have a difference of cubes. Because 1 could be a cube. Okay, sorry, so losing my voice. So if you remember, for cubes, we said that if we had a cubed minus b cubed, that was just a minus b times a squared plus ab plus b squared. So we can look at this and say, well, maybe a cubed is just my, or sorry, m squared is just my a. And b is just going to be my 1. So if I fill this out such as we have down here, well, then I have a, which is going to be m squared, and then I have minus 1 for the b. Then I'm going to have, we have a squared, so we're going to have m squared squared plus m squared times b, which is 1, plus 1 squared. Okay, so we got it matching a difference of cubes. You may have more you can do after that. So I have m squared minus 1, and then I have m to the 4th plus m squared plus 1. Now this can actually be broken down further because I have m squared minus 1, which is just m squared minus 1 squared. So a difference of squares. So we had a squared minus b squared, which is a plus b times a minus b. So this can be broken down further as m plus 1, m minus 1 times m to the 4th plus m squared plus 1. And it's always best to kind of check that this was actually working correctly. So we're going to do that here just a bit, make a little space. So I have m plus 1 times m minus 1 times m to the 4th plus m squared plus 1. So we're going to double check and make sure that this worked correctly. Like I said, I'm not going to do this every case, but if I do this, I have m times m, or we have m squared minus m, and then we're going to have plus m minus 1 times 1, which is 1. So that's just these two together. So we have m squared minus m plus m minus 1. And multiply that to m to the 4th plus m squared plus 1. So we know that's m squared minus 1 to m to the 4th plus m squared plus 1. All right, so if I go further, we get m squared times m to the 4th, so m to the 6th, m squared times m squared, so m to the 4th, m squared plus 1, so m squared. Then we have negative 1, m to the 4th, so negative m to the 4th, negative 1 times m squared, so negative m squared. Negative 1 times positive 1 is negative 1. My m to the 4th cancel, my m squares cancel, and I'm left with m to the 6th minus 1. So yes, I did get the correct factorization down here. So another example, we have a trinomial. So one of the things to look for here is, before I start even factoring the trinomial, and we've seen this before, is we want to make sure, do I have a common factor? So we have a 4, a 14, and a 12. All of those are divisible by 2. So I can pull it at 2, and I'm just having 2 squared minus 7x plus 6. So this can't be factored, can't be have any more greatest common factors. So we're going to use AC method. So my A is going to be 2, my C is going to be 6. So AC is going to be 12. So I need factors of 12. That should sum to negative 7. So if I look for that, what I'd have is negative 3. Remember, it's a positive 12 here. So negative 3 and negative 4 will give me positive 12. And if I add those together, I would get negative 7. Okay. So we have that 2 is still there. We can kind of ignore it. But what we're going to have is 2x squared minus, you can do 3x minus 4x. Like I said, doesn't matter which way we do it. All right, so we're mostly going to ignore this 2 again. So I'm going to put brackets around this as I do it. All right, so what can I pull out of 2x squared plus 3x? Well, just x, and I'm left with 2x minus 3. What can I pull out similar from 4 and 6, or minus 4 and 6? Well, I can pull out a negative 2, leaving me with positive 2x minus 3. So I have that 2. I can pull out a 2x minus 3 from both of these, and then I'm just left with x minus 2. Okay, and like I said, if you want to, you can go back and check that. Okay, so this one here, we have m squared minus 4b to the 4th plus 14m plus 49. So we want to factor this one. So you could try factoring by groups if you wanted to. That could work. One of the things I noticed here is that some of my terms have m and some do not. So if I put these together with an m, and I have the 49 and the minus the 4a to the 4th, if you notice here, we have, where this would be 7 squared, and this is 2 times 7. This is actually a square. This part here is actually m plus 7 squared. So this is what we mean by looking for squares. Sometimes if we look, we can find something that we actually know how to factor. Oops, that was a minus 14. That's a minus negative 7. That's a negative 7 squared. So we'd have m minus 7. So you could actually factor the m squared minus 14m plus 49 into m minus 7 squared. And then we still have that negative b, 4b to the 4th. So if you look at this, got a square here. I'm going to see if we can turn this into a square. So I have 4 squared b squared squared. So we're just using rules of exponents. And one of them says that if I have 2 numbers multiplied together that have the same power, I can pull that power out. So if I have 4b to the 4th, I can rewrite that as 2b squared, all of that squared. And now we have a difference of squares. Oops. So we know we have a difference of squares. This is going to be all my A and this is all my B. So A is going to be m minus 7, and then we're going to have plus B, which is 2b squared. And then we also have, for A minus B, we're going to have m minus 7 minus 2b squared. Or we can look at it as just saying, if I drop parentheses in places, m minus 7 plus 2b squared times m minus 7 minus 2b squared. So admittedly, this one's not the one it's so easy to notice right away. Admittedly, I actually messed this one up the first time because I just tried straight factoring by group. Like I said, just briefly just going through a few examples of things to kind of look for when you are trying to factor something, that sometimes you can factor it, and not only that, you could factor it a little further. So like we could factor this part, and then we realize that this is a square, and then we realize that this is a difference of squares. So like I said, just looking for those patterns in there so you can keep factoring something further and further with everything that we've learned.